I didn't waste time today like doing a quick review like we do other days. One, because I felt like we reviewed a lot of this last Friday, or 2 Fridays ago now, I guess, where we converted from degrees to radians. The one conversion that is a little tricky is this one, because you don't see a pi. Technically, a pi is a decimal. So if you were to go like on your calculator and you type in pi divided by 3, that's 1.04. So technically, a radian is a decimal. So if you're given a decimal and it does not have a degree symbol after it, then this is in radians. So you would convert it from radians to degrees. What I also want you to notice is I did put over here the all students take calc again, but this time on it, I have decimal numbers. So when I just went on my calculator and I typed pi divided by 3, I got 1.04. So what that does is tell me that that radian is in quadrant 1. Because the radian values from quadrant 1 are 0 to 1.57. That 1.57 is representative of pi divided by 2. Here on the 180 line, it's 3.14 because that's pi. Down here, it's 4.71 because that's 3 pi halves. So sometimes when you get inverse trig values or you get like the sign of something, if we're in radians, you need to know what quadrant it's coming from. So for example, here it said the sine of x equals 0.6. And it said solve the equation graphically in the given interval. Well, the sine is going to equal 0.6. To find that, what you would do is you take your graphic calculator. The interval is 0 to 2 pi, so you're in radians. So you would want to make sure when you go to mode, you're in radian mode. And then you would do second sine, so you get sine inverse, type in 0.6, and you get that first answer, 0.64, blah, 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 blah. Well, sine of 0.6 is positive between 0 and 1.57, so that tells me it's in quadrant 1. Well, we know the sine is also positive in quadrant 2. So this is where you had to do what we talked about last week, which is to find the value in quadrant 2. So in quadrant 1, it's 0.6435 above the curve. So that means in quadrant 2, I need it to be that same distance above the pi curve on this side. So what you do is to find quadrant 2 is take pi minus whatever the answer was. So in this case, it's pi minus 0.6435, which gives you that 2.498 number. If you were going to go down, so if it was tangent, for example, tangent's positive here and here, this quadrant would be pi plus whatever that answer was. And this quadrant is 2 pi minus whatever, because you're going from 2 pi and down. So it's all with respect to the axis moving up or down. Talked about it that Friday, so I didn't want to waste time doing a quick review. Alright, so here is your unit circle. So again, I gave you guys that blank one. This is now recorded, so you could go up on the recording and find this. The only thing that's not on here are the degrees. So I will tell you now, in calculus, 95% of the time, if we are talking about trig, our answer will be in radians. So if we are talking about trig, or it'll be given to you in radians. It is very rare in calculus that you'll see like the sine of 30 degrees. Instead of being the sine of 30 degrees, it'll be the sine of pi 6. Sorry, just can't see. The third or the outside number is the tangent. So like all the numbers outside, these are the tangents. So I have a worksheet that I'm going to print for you tonight. It will be part of your homework. So it's just going through all those unit circle values because our textbook doesn't do it. But like I said, it's so critically important in here. Actually, when I taught at Trinity, I taught Algebra 2 there. Their AP Calc teacher gave them pop quizzes on like the unit circle like once a month. And I know that some of the pre-calc kids I tutor, they actually have pop circle unit. They do trig at the beginning of the year like you guys, but she gives them pop unit circle quizzes all year. Like they have them in June. So we don't do that quite as intensely, but we will review it. Like there might be a day you come in and I'll be like, okay, we're going on quizzes and you're going to do like 10 unit circle review questions just because I don't want you to forget. I myself even get to a point where I'm like, you know, and review them. The radian measure of the angle is known from the equation S equals r theta. So arc length is given by S equals r theta, where r is the radius and theta is the angle. So we can find the length of a piece of the unit circle by doing S equals r theta. So it says find the length of an arc subtended on a circle of radius 3 by a central angle of measure 2/3. So again, arc length is equal to r theta. R is 3. Theta is 2/5. So the arc length is 2 pi. This is not the unit circle, so it's not the whole circle. So again, if a radius is 3, it's not the unit circle. Radius of the unit circle is always 1. Hence the word unit. Unit means 1. Uni is like the prefix for 1. It's like bi is a prefix for 2. Tri is a prefix for 3.
Will the following students please report to the office? Ava Burrows, Faith Sampedro, and Addison and Alexis Durkis.
All right. So an angle of measure theta is in standard position at the center of a circle. So we say that the initial is the x-axis and the terminal is the angle. We can use that to identify the trig functions. You always have the terminal coming from the x-axis. So even here in this description, the terminal side is this right here. The angle could be calculated in one of 2 ways. The angle could be considered if this was 30 degrees above. You could do the angle all the way as 150, or the angle would be 30. Because you're talking about the angle with respect to the x-axis. So it's called the terminal ray, but again, the theta is typically from here to there. So if you're told an angle is in a trig function is in quadrant 2, then the angle is from the x and up. If it's in quadrant 3, then the angle is from the x and down, so on and so forth. So you always talk about the angle with respect to the x. It's not that huge angle. Okay, the 6 basic trig functions are defined as follows. Sine theta is y over r, where r is the radius and y is the height. X, y are the points on a unit graph. So like x comma y comes from a point on the graph. X, y could be in any quadrant, And that's how the signs come into play, meaning the positive or the negative values. So angle can go from radians to degrees and degrees to radians. I wanted to say conversion, and I was like, did they just spell it wrong? Like I said, chapter 0 is the only chapter I use on technical PowerPoints because a long time ago I didn't used to do chapter 0. I just did the summer packets, and then I found that we needed to. Alright. So find all the trig values of theta if sine of theta equals negative 3/5. So this is what I was talking about. You need to know what quadrant negative 3/5 is coming from. So sine is negative in quadrant 3 or 4. So right now it could be in quadrant 3 or 4. That's why we are then given the tangent value. So the tangent is also negative. Well, tangent is negative in 2 and 4. So the only quadrants in which they overlap is 4. So that means that this point is in quadrant 4. You don't hear that little kicker? Okay. So what that means is that in terms of this point, it's really 3, negative 5. So there is a negative, you just didn't know where the negative belonged, with the 3 or the 5 initially. So that means that this triangle looks like that. So the height of the triangle is the y values. Well, the y value is negative 5. So that's like saying x equals 3, y equals negative 5. I need to find r, because I can't find the other trig values without knowing r. R is also equivalent to like the h in Sokojoa. So like if you talk Sokojoa days, then this is my theta. So then theta is equal to this angle in the corner. So opposite is going to be the height, or x. Sorry, my r is 5. My y, we have to calculate. Well, because I said tangent to you, I treated it like tangent when I wrote them down. But sine is opposite over hypotenuse. Sorry. Okay, so sine is OH, so opposite is going to be my 3, and my radius is going to be my 5. So this is my negative. That's 3. So now I'm dropping this off. Sorry. I said tangent and looked at tangent. Drew on it. We just changed it to tangent. I wonder if I give you Bruce big names for the first one. So obviously if it's 3, radius 5, y is so the 4 represents the base, opposite, adjacent, hypotenuse all still match. So to do your trig values, sine is given. So sine, cosine, tan, cosecant, secant, cotangent. Sine and cosecant are just opposites, so sine is negative 3/5. Cosecant is negative 5/3. Cosine is A over H or Y over R. So it's 4/5. Now, cosine in quadrant 4 is positive. Therefore, positive. Tangent is negative, and that makes sense because tangent is sine over cosine. So tangent is negative 3/4. And then secant and cotangent flip. So 5/4, negative 4/3. Right, so there's another one. I will not keep going there. There's no one here. But I have your packets done and ready to pass back out, so we can talk about the packet ones. Alright, this is also maybe very similar to the problems that were in your packets. Because, once again, I gave you trig values and wanted you to find where they existed on the unit circle. So, do you want to take a minute and try on your own? And then we'll check them. And if you're not sure and you're writing ahead, just get it right down. Or you also do all my notes in red pen. It's a public problem. So, Lori, just use pencil. Yeah. So for those of you like that maybe forgot, all of the negative ones, you have to add 2 pi to them, which I was trying to write, but like the handwriting is like really glitchy on me right now. So like cosine of negative pi 6 is really like cosecant of 11 pi 6. And for whatever reason, I wrote pi 11 and it couldn't be reason, so hopefully that makes sense. So again, that's going to be like the cosecant and then the tangent of that factors. So it's like much harder to do it on the board than I feel like on a piece of paper. So I feel like I'm like thinking in my head or on a break. Are we okay with all of this? So textbook is going to be that. I'm going to print you a worksheet. These are our Pythagorean triples that we'll use most frequently in calc. So most of them you should know. The 3, 4, 5, 6, 8, 10, 10 are all multiples of 3, 4, 5. So to get to 6, 8, 10, you take all 3 numbers times 2. To get to 9, 12, 15, you took all 3 numbers by 3. So then you could multiply it 3, 4, 5 times any number and get a new multiple. And then 5, 12, 13 is the same as 10, 24, 26. It's just all those numbers times 2. There is another one, it's like 7. Let's see, I don't even remember. There is a Pythagorean triple with 7. I feel like 7, 12.